Hello. Today I'm going to talk to you about the transversal pink sheets, and we're using these pink sheets in Unit 4. So first of all of these theorems and postulates concern the same situation. You have some parallel lines and you have them cut by a transversal. So when are we ever going to use this page? It's when we're dealing with parallel lines. So you have the same situation. If two parallel lines are cut by a transversal, that's going to be the same for all four of these on the first side of the pink sheets. We have two parallel lines cut by a transversal. How do we indicate that they're parallel? We usually use a little arrow that shows they're parallel. These little, I think sometimes they're called feathers because they look like feathers on a bow and arrow, the end of an arrow actually. Anyway, so the corresponding angles postulate says if these two parallel lines are cut by transversal, then corresponding angles are congruent. Well, where are the corresponding angles? They're here. Angles 1 and 2. They're corresponding because they're in exactly the same spot. They're both in the upper left corner of this intersection between the transversal and each of the two parallel lines. So since they're both in the upper left, they have corresponding positions and we call them corresponding angles. As you can see, they look like they're the same size, and that's because they're congruent. So that's the corresponding angles postulate. The next one is pretty similar, but different sets of angles. Okay, so what's the takeaway? Angle 1 is congruent to angle 2. That's all we said in that figure. Alternate interior angles theorem is going to say if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So this is the key part of this one. And where are alternate interior? Interior means they're inside of the two parallel lines. And alternate means they're on opposite sides of the transversal. So we could say this is angle 3 and this is angle 4. Again, interior means they're both inside the parallel lines. Alternate means on opposite sides of the transversal. So they're alternate interior angles. And we, again, need our little feathers here to indicate that the parallel lines are parallel. And what we can do here is just say, well, they are congruent angles, so we know that angle 3 is congruent to angle 4. So that's alternate interior angles. The next one is same side interior angles. Again, if two parallel lines are cut by transversal, then same side interior angles are supplementary. This one is a little different because there's no congruent angles usually. But how do you remember this one? Same side supplementary. It's got some alliteration. SSS. Same side interior angles are supplementary. And what does that mean, same side interior? Interior, like I just said, means they're both inside of the parallel lines, but they're on the same side of the transversal this time. So that would be angle 5 and angle 6. So we can say the measure of angle 5 plus the measure of angle 6 equals 180 degrees. That's why they're supplementary. Okay, and alternate exterior angles theorem. This is somewhat similar to alternate interior, except instead of interior, this time they're exterior. Oh, yeah, I forgot to draw my feathers up above. That's easy to forget. So again, we have two parallel lines cut by a transversal. And we know that alternating exterior angles are congruent. That is what the alternate exterior angles theorem tells us, that those alternate exterior angles are congruent to each other. So alternate, remember, means opposite sides of the transversal. Exterior this time means they're outside. Both angles are outside of the parallel lines. So that could be like here, angle 7 and angle 8. They're congruent to each other. So we're going to write a single arc around each of them. So since they're congruent, we can say angle 7 is congruent to angle 8. So as you saw on this first side of the pink sheets, 3 out of the 4 theorems state that, or postulates, state that angles are congruent to each other. The only one that was supplementary was the same side interior angles. All the others are congruent. So the second side of your pink sheets is basically the same thing, but going in the reverse. So we have converses. The converse is like a related statement for what we learned on the first side. Corresponding angles theorem told us, corresponding angles postulate says if we have 2 parallel lines cut by transversal, then the corresponding angles are congruent. This one says a different order. If you have 2 lines cut by transversal, and we know that some corresponding angles are congruent, the only way that's possible is if those 2 lines that we talked about at the beginning are in fact parallel. So we're basically concluding from the given information that the lines must be parallel. So let's call this line L and line M. And we're going to say corresponding angles 1 and 2 are congruent to each other. So angle 1 is congruent to angle 2. And since they're corresponding angles and they're congruent, and we have 2 lines cut by a single transversal, the only way this is possible is if line L is parallel to line M. So line L and line M must be parallel to each other. That's basically what this converse says. And all the converses are basically going to say the same thing. If you have this situation, it's only possible when those lines are indeed parallel. Alternate interior angles converse says something similar. If 2 lines are cut by a transversal, but this time you have alternate interior angles being congruent. So let's say angle 4 and angle 3. If those 2 angles are congruent, angle 3 is congruent to angle 4. The only way that's possible with 2 lines cut by a transversal is if those 2 lines, let's call them X and Y, line X must be parallel to line Y. So all these converses say if you have this situation, then those lines must be parallel. That's the only way it'll ever happen. Same side interior angles converse is dealing with same side interior angles, obviously. So let's say we have lines A and B cut by a transversal, and this converse says if 2 lines are cut by a transversal and the same side interior angles are supplementary, then the lines must be parallel. So let's call this 130 degrees, and we'll call this 50 degrees, and we know 50 degrees plus 130 degrees is equal to 180 degrees. I ran out of room there. So 50 plus 130 is equal to 180. So we know they're supplementary since they add up to 180. Well, what's our conclusion? The only conclusion we can really make about those two lines A and B is that they're parallel. So line A is parallel to line B. These are all going to be the same for these first four converses. Alternate exterior angles this time. Let's say we have lines C and D cut by transversal, and we'll call this angle 5, angle 6. Two lines are cut by transversal and alternate exterior angles are congruent. So these are my alternate exterior angles. I know angle 5 is congruent to angle 6. Then that's only possible if these two lines, C and D, are parallel to each other. So line C is parallel to line D. This last one is the only one that's really different on these two pink sheets. It doesn't really have a corresponding postulate or theorem on the other side. The perpendicular transversal converse says if two lines in a plane are parallel to the same line, are perpendicular to the same line. So let me try to draw that. I'm going to say we have line X and line Y. They're both going to be perpendicular to this line A. So there you have our drawing. Two lines, X and Y, are both perpendicular to the same line A. So we can say line A is perpendicular to line X, and line A is also perpendicular to line Y. So both lines X and Y are perpendicular to line A. How is that possible? Well, that's only possible if lines X and Y are parallel to each other. So you can see on the right column, all of these situations involve two lines being parallel to each other. This is really just a special case for perpendicular lines. Okay, that's the pink sheets for Unit 4.